Okay, so this is Dr. Lennon back with the third video to finish up the test review. So in problem 10, we're assuming that 81% of drivers wear seat belts. They set up a safety roadblock stopping cars to check for seatbelt use. How many cars do they expect to stop before finding a driver whose seatbelt is not buckled? That's the same formula before. When you have a percentage like that, 1 over n is giving you that expected value. So in this problem, that's 1 over 0.81. So, oh, excuse me. I think they asked the complement how many before they find one whose seatbelt is not buckled. So 81% buckle, which means we should be looking at dividing by 0.19, that complementary probability. So we don't want 81, we want 0.19. All right, good enough. So 0.19 here instead. Punch that into the calculator. So that gives you 5.26. There's more decimals too, but I don't know how many they ask for. 5.26, yeah. All right, so there we go. What's the probability that the first unbelted driver is the 5th car stopped? So this is a very particular order. It basically means that the first 4 drivers all have to be belted, and the 5th one is unbelted. So that amounts to just saying, okay, the first 4 are all belted, and it has to be in that order, so 0.81 to the 4th. And then we have to multiply by 0.19 after that. So that's the probability. So 0.81 to the 4th power times 0.19 is, I don't know how many decimals they want, but 0.0818 if we round to 4. 0.0818. They want 3, so we're doing 0.082. And then what's the probability that the first 12 drivers are all wearing their seatbelts? So that's 0.81 12 times in a row. So you'd have to multiply 0.81 12 times, or 0.81 to the 12th power. So that comes out at 0.080 if you round for this one. All right, so if they stop 25 cars during the first hour, find the mean and standard deviation of the number of cars expecting to be wearing seatbelts. Okay, so this is just a binomial mean where n is equal to 25. So again, our mu here would be 0.81 times 25. So this comes out to 20.25. So we would expect 20.25 drivers. I don't know if it's gonna, okay. It didn't say anything about the decimal places. Then the standard deviation, this is the same, so this was 20.25. And then standard deviation is going to be the square root of 0.81 times 0.19 times 25. And let's see what we get when we do this. So that comes out to 1.962. So 1.96. If they stop 120 cars, what's the probability at least 34 are not wearing their safety belts? So we're going to have to go back to StatCrunch, and we have the binomial distribution up. So now n is equal to 120, and the probability of at least 34, so is it 34 wearing or not wearing? At least 34 are not wearing their safety belts. So the probability of not wearing was 0.19, and then greater than or equal to 34, at least 34. So that's 0.0084, 0.0085 if you round to the 4th decimal place. All right, second to last question coming up. All right, so again, we've got a situation here where we have a company reported that the retention rate of first-year students was 73%. We're considering freshman classes of 500. Use the 68, 95, 99.7 rule to describe the percentage of students. So again, we know 73% has to be the middle number, so it's A or B, and then we want to figure out exactly what the standard deviations are. And when you have these percentages, we only had 1 or 2 examples of this in class, but the formula here is the square root of, so when you have these proportion ones, it's the square root of PQ over N for these sampling distributions, because that's essentially what's going on. We're looking at a class of 500, and P is 73%. So this, for us, is going to be the square root of 0.73 times 0.27 being divided by 500. So let's do that in the calculator. 0.73 times 0.27 divided by 500, and then take the square root. So this comes out to a pretty small number, something like 0.0199. So about 0.02. So when we look at this problem, we want the middle to be 0.73, and we want to see one standard deviation look like about 0.02 rather. So if we look at this one, it's essentially between A or B, whichever one. So 0.73, this looks like it's going by 0.01, so this looks like 0.75 here, so this should be the correct one. So it should be A. All right. And then are the conditions to use a normal model met? So this one's kind of subtle, and the point is colleges with freshman classes of 500 students aren't representative because many colleges aren't going to be having sample sizes that large. So essentially that means we can't be taking a simple random sample of all the colleges. So in this case, the randomization condition is not met. And the last question. So we're doing one where we actually use a sampling distribution. So the weight of potato chip bags is stated to be 10 ounces. The machine that puts them together, they use a normal, they think is a normal model with mean 10.1 and standard deviation 0.07. What percentage of bags sold are underweight? So we could use the normal model on StatCrunch again. So let's go back to the normal calculator. So stat calculator, normal calculator. And so for us, the mean was 10.1 with a standard deviation of, what does it say, 0.07? 0.07. So we're trying to figure out what percentage are actually under 10, the amount that they advertise. So 4 decimal places, that's 0.0766 when you round up to 5. Okay. Some chips are sold in bargain packs of 5 bags. So what that means is now we're looking at sampling groups of size 5. So when you have a sampling distribution like that, what happens is for these sampling distributions that aren't proportion ones, so the sampling distribution mean is actually just equal to the regular mean, but the sampling distribution standard deviation is actually sigma divided by the square root of n. So in this example, sigma was equal to 0.07, so our standard deviation, or our sampling distribution standard deviation is 0.07 divided by the square root of 5. So that comes out to something like 0.0313. It says it says the probability that none of these 5 bags is underweight. So the probability that none of the 5, we don't actually move to the sampling distribution yet. So I did the part for part C a little prematurely. So the probability that none of them is underweight. Well, the probability that they that none of them is underweight, which means all 5 of them make weight, and so essentially it comes down to the answer from part A. So we figured out the probability of a single bag being underweight is 0.0766. So the probability that none of the 5 would be underweight is 0.0766 raised to the 5th power. So each one of those would have to happen. So 0.0766 raised to the 5th power gives you a very, very small number. So if you do it, you get something like 2.63 times 10 to the negative 6th. So I think this just comes out to 0. No, hold on. Oh, I know what I did again. I read it the wrong way. It's the complement. Since none of the bags is overweight, it's all of the bags being... So the complementary probability to the one above would be 1 minus 0.0766, which is 0.9234. So we need to do 0.9234 to the 5th power. And that comes out to 0.6714. So what we did was for B, we did 1 minus the probability from part A, then raised that to the 5th power. So for C, now we're trying to find the probability of the mean weight is now below the stated amount. So essentially that's what we did here. We found the sampling distribution standard deviation. So we'll go back to StatCrunch and change that standard deviation to 0.0313 and compute the probability that it's less than or equal to 10. So that's 0.0007 if they ask us to round to 4. And that checks out. And then for D, they're saying what's the probability that the mean weight of a 30 bag case. So now we're looking at a sampling distribution where the sample size is now 30 rather than 5 in the previous example. So the new sampling distribution would be 0.07 divided by the square root of 30. So that comes out to something even smaller. So 0.0128. So to answer the same question on that sampling distribution, we just go back to StatCrunch and change this to 0.0128. Hit compute, and we get that e to the negative 15th means move the decimal 15 places to the left. So this is going to be essentially equal to 0. Alright, so that's it for the test review. Hopefully that was helpful, and good luck on the test tomorrow.